So I just want to go over a few of the section 7.1a and 7.2 problems for Mr. C's exam. And let's see. Okay, there, yep, recording is on. We'll just begin with, let's see, I think we'll just go from 5 and keep going down. Go through as many of them. Which that is the area from -1 to 1 of, oh, you know what, I should probably pull these up in the problem because that's probably the first step they want it set up. I should probably not use solutions. Yeah, hopefully everyone enjoyed that quiz that we just had. That was very, I guess, informative for what's probably going to be on the exam from that section. Okay, let's see. Ebook. Okay, and this is 7.1. Exercises. Okay, there we go. So it says sketch driven by the curves. Decide whether to integrate with respect to x or y. Draw a typical approximating rectangle and label its height and width, and then find the area. So for 5, we got y equals e of x, y equals x squared minus 1, and then the bounds of x equals -1 and x equals 1. Okay, so let's get a chart here. And let's add some of the lines there. So we have the bounds x equals -1 and x equals 1. Then we have the equation y equals x squared minus 1. So that means at 0, y is going to be -1. And we're also going to have these points right here for when x equals 1 or -1. and then y equals e of x. At 0, that is going to be equal to 1, and it will go to some value here and there. So what we're going to want to do is integrate with regard to the x-axis. So our top function is going to be y equals e of x, and our bottom function is going to be y equals x squared minus 1. So we're going to take the integral from -1 to 1 of e to the x minus x squared minus 1 dx. So we'll distribute that negative sign. E to the x minus x squared plus 1 all to dx. And then we can integrate. So we don't need that. So now we'll have e to the x minus x to the third power over 3 plus x, all evaluated from -1 to 1. Then we can input, so we'll have e minus 1 over 3 plus 1 minus 1 over e minus -1 to the third power, which will be -1 over 3 minus 1. So then we simplify, so e minus 2/3 minus 1 over e plus 1/3 minus 1. Then we're going to need to make sure to distribute. So e to -2 over 3 minus 1 over e plus, so we have 1/3 minus 1, that is opposite 2/3 with a minus, so that'll be 2 over 3. So our final answer should be equal to e minus 1 over e. And let me just check that against the solutions given. No, I think I did a error here. So this is b minus 1, so this turns into a plus. Here, let's see. I skipped a step and it did not work out. Actually, we don't need those there. Okay, let me see where I messed up at. So this is e minus 1 over 3 plus 1 minus 1 over e plus 1/3 minus 1.
Wait, go back up. I think where you put the to the right side 1 over e minus the -1 cubed. Shouldn't it be minus? Or wait, no.
Yeah, it's minus a minus, so it should be positive.
And then did you distribute it out to be? Oh, okay, no, never mind.
Let's see, because then that was x, which is just -1 here. I got e minus 2 over 2/3. Unless I did this wrong. No, yeah, because this is supposed to be a positive 2/3, not a negative. That would be where I messed up. I just didn't add these correctly, so. All right, got that figured out. So this will be 1/3 plus 1, so that'll be 4 over 3 minus 1 over e, which lines up with the solution. All right.
What teacher do you have for calc?
Mr. C.
Oh, okay.
All right, so from here, I guess we will go on to number 6, which is y equals sine x, y equals x, x equals pi over 2 and x equals pi. And then we will draw our xy. And we will put, actually, here, let's see, can I get this? There we go. So we're going to want pi over 2 and pi, because it looks like those are going to be the bounds. So we know for y equals sine x at pi over 2, it is going to be at 1, and then at pi, it will be back at 0. And then for y equals x, well, we know that pi is around 3, so we can put 3 around there. So we're going to be finding this area right here, which we can draw our box, which I would say we will integrate with respect to x. All right, so that means y equals x is going to be our top function, and y equals sine of x is going to be the bottom. So we're going to have the integral from pi over 2 to pi of x minus sine x dx. And then we will integrate. So we'll have x squared over 2 minus cosine x. Let me just check sine, cosine, opposite sine, opposite cosine. That is for derivative, or no, for integration. Yes, so it'll just go to cosine. And actually, it should be positive cosine. From pi over 2 to pi. All right, from there we will plug in. So we're going to have pi squared over 2 plus cosine of pi minus pi over 2 squared over 2 plus cosine of pi over 2, which will be equal to 0. So we're going to get pi squared over 2 plus, actually it'll be minus 1 because cosine of pi is negative 1. And then we will distribute this minus. So we're going to have minus pi over 2 squared over 2 plus, and then cosine of pi over 2 is 0. So pi squared over 2 minus 1 minus pi squared over 4, all of that over 2 plus 0, pi squared over 2 minus 1 minus pi squared over 8. Then we'll just check the answer real quick. Or actually, I don't think 6 actually wasn't on there. Should just skip down to 7. All right, well, then we just did that one to do it. No harm in doing extra practice, I guess. So we're gonna, for number 7, we are going to have y equals x minus 2 squared, and then y equals x. All right, so let me just set you with the ticks. So for y equals x, it's just going to go up by 1 each time. Then y equals x squared minus 2, that'll be x squared minus 4x plus 4. Which means when x equals 0, it's going to start up here at 4, and it looks like, you know what, let me set these equal to each other. So we're going to have x minus 2 squared equals x. So x squared minus 4x plus 4 equals x minus 1x over, so x squared minus 5x plus 4 equals 0. And then let's see, can we factor this? Well, I can take an x for x minus 5 and set that equal to opposite 4, but that doesn't really get where we want to go. Okay, I think I might be seeing this one right here wrong. Maybe. Because it's on the inside, so it shouldn't really have, oh no, never mind, yeah, so it's going to be 4 up here, and that should be shifted 2 to the left right there, which means it should go up there to a certain point, and then over there across at a certain point. That still doesn't solve this, so see, can I try oh yeah, I can factor this. So x minus 5, and then x minus 1. That will get us to 0. So x equals 1 and x equals 5. If I did that correct. Oh no, this is supposed to be 4. Whoops. And x equals 4. So now we got our bounds of being 1 and 4. I just didn't see the factoring right away. So we're gonna get the integral as y equals x is going to be our top, and then y equals x minus 2, all that squared, is going to be our bottom. So we're going to take the integral from 1 to 4 of x minus 2 squared dx. And we can get dx by drawing our rectangle right there. So we're going to get from 4 to 1 of x minus x squared minus 4x plus 4 dx. So we're going to have from 1 to 4 of x minus x squared plus 5x minus 4 dx, combine like terms. So it'll be 6, or we'll begin with, 6x minus x squared minus 4 dx. And then we can integrate. So we're going to have 3x squared minus x to the third power divided by 3 minus 4x, all evaluated from 1 to 4. And we can input our values. So 3 times 4 squared minus 4 to the third power over 3 minus 4 times 4 minus then 3, and since we know it's just going to be 3 because x squared, or 1 squared, is equal to 1, minus 1/3 minus 4. So we have 3 times 16 minus 4 times 4 is 16 times 4 is 64 over 3 minus 4 times 4 is 16 minus 3 plus 1/3 plus 4. So 3 times 16 is going to be 48 minus, we can combine those, so 63 over 3 minus 16 minus 3 plus 4. We have 48. 63 divided by 3 is going to be, well, it's divisible, so let's get rid of that real quick. 21, and then minus 16 plus 1. So we're going to take 48 minus 16, that's going to be 32 minus 20, which will be 12. And our answer for this one is not 12, and I think I'm a bit off. Let's see. Yes, now it's trying to figure out what I did wrong. (64/3). That's correct. Did I forget? Let's see. So when I brought that down, I brought it down for 3/2. No, 3. So 6 divided by 2 is equal to 3/2. Oh, I see what I did, I think. When I brought down a 5 right here instead of a 4, which means that this is supposed to be 5x, which will mean 5/3 right here, which means all of the algebra I just did was wrong. Whoops, that's kind of an issue. So let me just get my pen back out. 5 times 16/3 minus 64/3 minus 16 minus, and then that'll be 5/3 minus a third minus 4. All right, so 5 times 16, I believe that is 80. 80/3 minus 64/3 minus 16 minus, so 5/3 minus 1/3, that's 4/3, but it's minus, so opposite 4/3 plus 4. 80 minus 64, that is going to be equal to 16/3 minus 16 minus 4/3 plus 4. And we can subtract more, so that's going to be 12/3 minus 16. Well, actually, let's add the 4 into there. So minus 12. That'll be 12 minus, well, 12/3 minus, actually, no, we can simplify that. And I think I got it wrong again. At least according to the answer on the guide. Does anyone see what I'm messing up on, or? It says from the integral of 0 to 4 should equal -1/3 plus 5/2. Okay, never mind. That would explain it again. Let me just make sure I actually got it right one more time, because I don't want to go through again and mess up one more time on math. -4. Okay, there we go. I'll try this one more time. If I don't get it right, I'm just going to move on to the next problem, because otherwise it's messing up on the same thing 100 times. 5/2 times 16 minus 64/3 minus 16 minus 5/2 minus 1/3 minus 4. So we're going to get 5 times 8. which is going to be equal to 40 minus 64 over 3 minus 16 minus 5 over 3. Now 5 over 2 plus 1 over 3 plus 4. 40 minus 16 is going to equal to 24. We're going to put plus 4 right there. Minus 63 divided by 3 minus 5 over 2. So that's going to be 28 minus 21 minus 5 over 2. That's going to be 7 minus 5 over 2. So 14 minus 5 over 2, or 14 over 2 minus 5 over 2, which is going to equal 9 over 2, which is the correct answer. All right. If I didn't make that many mistakes, it would have been nice, but I guess it happens. So let's go on to number 9. So 9 is x equals 1 minus y squared. X equals y squared minus 1. So we're going to draw out our shape. So y squared minus 1, so when x equals 0, y is going to equal opposite 1. When x equals, or no, when y equals 1, no, I did that wrong. So when y equals 0, x equals negative 1. When y equals 1, x is going to equal 1 and minus 1. So we're going to get like that. And then for the other one, 1 minus y squared, when y equals 0, x is going to equal 1. And when y equals 1, we are going to get this shape right here. And it's going to be easiest to integrate with respect to x, or no, with using a change in y. So never mind, to y. And I believe we're going to have an even function in a second, but we should probably, I guess the top one is going to be considered this one right here, because it has the higher x. So y squared minus 1 is the top. So we're going to take the integral from negative 1 to 1, and we could set these equal to each other, but we can kind of see it, of y squared minus 1 minus 1 minus y squared, all of that times dy. So we're going to take from negative 1 to 1, y squared minus 1 minus 1 plus y squared dy. So we're going to get the integral from negative 1 to 1 of 2y squared minus 2 dy. And then it is an even function. So that means we could take a 2 out to the front. And we can take from 0 to 1 of 2y squared minus 2 dy. So now we're going to integrate, and we're going to get 2 over 3y to the third power minus 2x from 0 to 1. So we're going to get 2 times 2 over 3 times 1, which will just be 2/3, minus 2, and minus 2. Oh, this is supposed to be a y. Because the rest of that should be 0, and I think I did something wrong as I'm getting now a negative. let's see, y squared minus 1. Unless this was supposed to be the top over here on the other function, but yeah, yeah, I think so. So this is not supposed to be the top. This is supposed to be the top. Which, I mean, we could just simply take a minus out, but might as well just redo it just to have it done correctly. So it's going to be from -1 to 1 of 1 minus y squared minus y squared minus 1 dy from -1 to 1 of 1 minus y squared minus y squared plus 1 dy from -1 to 1 of 2 minus 2y squared dy. We can then, because it's positive, we take a 2 out, and it's going to be from 0 to 1 of 2 minus 2y squared dy, and I guess we can also take another 2 out because it's on the inside. We can factor a 2 out, so we'll get 4 from 0 to 1 of 1 minus y squared dy. And then we can integrate. So that's going to be y minus y squared to the third power divided by 3 from 0 to 1. So that's going to be 4 times 1 minus 1 over 3. The rest of that's going to be 0. So it's going to be 4 times 2 over 3, which will equal 8 over 3. Oh, I had an extra 2 on the previous one. Let's see. Plus 2 minus 2. I mean, I was just going to check the answer for the other one real quick. Yeah, and this one is correct of 8 over 3. But I think I used it's supposed to be 1 minus y squared, so yeah. I just did it initially wrong. I selected the wrong top function. Okay, so now we're going to go on to number 11, which is y equals 12 minus x squared, and then y equals x squared minus 6. This one here doesn't, oh wait, no, we still need a sketching. Yep, okay, then we can do that real quick. Otherwise, it's still worth sketching. Okay, so actually I want to make this a little bit bigger, and I'm also going to make this a grid. Okay, so I'm going to set them equal to each other. So 12 minus x squared is going to equal x squared minus 6, but I can solve that in a second. Let me just check. Oh, that was, okay, never mind. Solve that out. So I'm going to just set let x be 0. So y is going to equal 12 when x is 0, which means I can probably make each of these count 2. And then, so for this one, it is going to look something like 2, 4, 6, 8, 10. So when we let x equal 1, it's only going to go down 1. When x equals 2, that's going to be minus 4. And I just realized. Then y squared minus 6. When we let x equals 0, we get y equals negative 6. And when we let x equals 2, we're going to have y equal minus 2. Or plus 2. So when we set them equal to each other, we want to get all terms on one side. So we're going to have 2x squared minus 18 equals 0. We can factor a 2 out, so that is x squared minus 9 equals 0. 0 is then going to equal 2 times x minus 3 and x plus 3. So x is going to equal plus or minus 3. Which means it's going to happen right there and there. So that gives us the bounds. So now we are going to take the, we're going to set this equal to the top and this one right here to the bottom. So we're going to take the integral from opposite 3 to 3 of 12 minus x squared minus x squared minus 6 dx. And might as well get the little rectangle in there. Alright, so we are going to take the integral from negative 3 to 3 of 12 minus x squared minus x squared plus 6 dx. And that'll be from negative 3 to 3 of 18 minus 2x squared, which also happens to be an even function. And we can factor a 2 out. So we're going to have 4 times, actually this will be 0, to 3 of 9 minus x squared dx. So from here we will integrate, so we'll have 4 times 9x minus x squared over, no, x to the third power minus over 3 from 0 to 3. So we will get 4 times 9 times 3 minus 3 to the third power over 3 minus all 0. That'll be 4 times 27 minus 27 over 3, which we can simplify that to negative 9. So 4 times 27 minus 9, so 4 times 18, which that should be 162. I think it looks a little too high for it to be the correct amount. I think I did some of the subtraction incorrect.
Wait, scroll down.
Mm-hmm.
Why did you do 18 by 9?
Oh, it's not 18 times 9. Oh, the 18 times 9? Yeah, that should be 18 times 4. That's probably the issue that I have. But that's still too high for the answer.
No, 18 times 4 is 72.
It is? Am I just doing it? Oh, I think I'm doing it wrong because that's supposed to be 20. Oh, that's supposed to be 32. Okay. Yep, never
There you go.
mind. I just can't
Yeah.
do basic multiplication.
That's okay.
Yeah. Who needs multiplication anyway? That's only like 3 points on the test or something.
You can do everything else, so.
Yeah. Plus, we get a calculator, which I'll probably be using to double check out my math at this point. So now we got 11 done. I should we go on to some of the challenge problems for 7.1? I think we as well.
Sure.
Because the idea behind it, like this is not crazy, but I know the challenge problems are going to come up and they're going to look like crazy or something. Something to throw us off. Okay, let me just try and copy this over. Or actually, it's 7.128. Let's see, can I just pull it up on MindTap? Okay, yes. And let me just get a screenshot of this. And I believe he did this problem in class, but we can still do it here just to refresh memory. If I remember, he did this at the very end of class. So the first question is, which car is ahead at 1 minute? So right here. Well, this is the velocity graph, which means it's going to be the area under the curve. And since A has a greater amount under the curve, it's going to be A. Let's see, then what is the meaning behind the area of the shaded region? So, because if B covers this area right here, A also covers this area, but A also covered all of this area. So that is going to be the distance A is ahead. Well, which car is ahead after 2 minutes? All right, so we're going to have to take a look at this area also and see if it is greater than or less than this area right here. Which, let's see, we can say that this plus maybe this is around 1. And then I guess this might be around 2 right here. Let me undo that. So 1. And this is around the other one. So we'll have, say this area is 2, and then this we have around 1. This is around 1 right here. This looks to be around another 1. And this looks to be around another 1. So this is 3. So car A is still going to be ahead. And estimate the time at which the cars are again side by side. They're probably going to need around 1 more block, which looks like it'll be right here. So that'll be 1, 2, 3, 4, around 2.25 minutes. All right, is there anything else we want to do on this one, or just head on to the next challenge? Okay, I think we will move on to 31. This was a pretty interesting one, I guess you can say. So let me just take another snip. Okay, so we got the birth rate of a population is B of t equals 2,200 e to the 0.024 t people per year, and the death rate is 146 e times 0, no, to the e to the 0.018 t power. Find the area between the two curves. What does this area represent? All right, so I actually think I remember remember seeing this one a while back on one of the web assigns, not my lab. So we got from 0 to 10, whatever, just to say, yeah, t equals 10, so this is going to be years. And now we got to just put some fake numbers in for the y-axis. So I guess let's say when t equals 0, that means it's going to equal 0 at the top. And e of 0 is equal to 1. So this is going to be 1460, and this will be 2200. And then when it equals 10, well, it equals a number greater than 1, so it's going to slowly increase over that time. So you have to find the area right here, which means we're going to have to take the integral of 0 to 10 of the bt minus dt, as the death rate should be lower than the birth rate to begin with. So it'll be 2200 e to the 0.024 t minus 1460 e to the 0.018 power, or 18 t power, times dt. Some of the revolving solid, yeah, we can get to that after this one right here. But yeah, like the volumes, yeah, I'll make sure to get to those. So I'm going to just split this up into two integrals. Just so I can actually take these thousands out. And then I believe it's easiest to set some u's. So u is going to be equal to 0.024 t, which will mean du is going to equal 0.024 dt, which is going to mean 1 over 0.024 is equal to dt for this left-hand side. That's just because so it makes e a lot easier to integrate. So 2200 divided by 0.024 from 0 to 10 of e to the u du minus, and we'll do the same thing over here, except we're going to use w. So then we can take the integrals. Oh, we don't need that, we just need the evaluation. And the limits are no longer 0 to 10 until we get them back, so I'll just put alpha to beta. Then we can resubstitute back in. So that'll be e to the 0.024 t from 0 to 10 minus 460 over 0.018 to e to the 0.018 t from 0 to 10. And we could evaluate this, but that's just going to be a lot of algebra. Does anyone want me to, or could we just go to the revolving, like the volumes? Or what Ethan said. This should be around 880, no, 8,868 after you solve the entire thing, which is a lot of work. Not that work is bad, but, well, yeah. So from here, I guess we can go on to some of the 7.2. And we don't want to, probably don't want to begin with the challenge problems for that. Okay, so we can do 7.2, number 1. So it's find the area of the shaded region, and then they give us a chart to use. Wait, I mean 7. No, this is still 7.1. Never mind. Whoops. Okay, so this is find the volume of a solid obtained by rotating the area bounded by the given curves about a specific line. Sketch the region, the solid, and a typical disk or washer. So for number 1, we're going to have y equals 2 minus 1/2 x, y equals 0, x equals 1, and x equals 2 about the x. All right, so we're going to need to sketch this. That is just about close enough. All right. So at y equals 0 right here. Oh wait, no, that's not y equals 0, that's x equals 0. Whoops. Let me just redraw that entire thing. All right. So at y equals 0, which will be along the x-axis, x equals 1. So let's set our little ticks. And x equals 2. That means it's going to happen in that thin band right here. So we have y equals 2 minus 1/2 x. So when x equals 1, actually, when x equals 2, we're going to get that y equals 1. When x equals 0, we're going to get that y equals 2. And that any value, I believe, above that, when x equals 4, it's going to equal there. So it's going to look like this. So then we're going to have to find the area of, let's see, y equals 0, and I just realized these aren't x equals 1 and x equals 2. One of these days I will get it right. So now we're just going to draw our the ghost side of it. I guess you can call it that. And actually, it is linear, so we are going to have to find the area, or the disk right here. So our integral is going to be, we're going to be using dx, and we're going to go from 1 to 2, and we're going to take the area, so we're going to have to figure out what r is. So r is going to equal y, and then ry equals 2 minus, well, let's see, r equals y, which equals 2 minus 1/2 x. So we're going to take the integral of 2 minus 1/2 x dx. So the integral from 1 to 2, and actually we can just integrate it right away. Why not? So it's going to be 2x minus 1 over 4x squared from 1 to 2. And then we plug in, so we're going to have 4 minus 2 squared is 4 over 4, so that is 1 minus 2 minus 1 over 4. And I just realized my pen is lagging a lot. Let me just try something real quick. Okay. 1 over 4. There we go. And that's supposed to be a minus. All right, so we got 3 minus 2 minus 1, 4. That's going to be 7 over 4. So then we're going to have, we're going to multiply this by 4 on top. So it's going to be 12 over 4 minus 7 over 4, which is going to equal 5 over 4. And then let's just check the answer real quick. Make sure I didn't make any mistakes. And I just realized I forgot the 2 pi. Yeah. Wait, I'm just checking. Can anyone hear me? Hello, sorry. I think my computer, it did not like that. And yeah, I had the setup incorrect. I forgot my 2 pi. Because this is supposed to be 2 pi times it. Because that's r. So it should have been 2 pi, because it was supposed to be 2 pi r squared. Yeah. Hey, I guess this is why we do it now. I will not be making this mistake, and hopefully no one else will on the exam. Oh, and is it only pi r squared? Oh yeah, because pi r squared is area, yeah. So it should only be pi r squared. Okay, well, there's a couple of mess ups. Yeah, because the 2 pi is for the diameter, which is for doing it by doing the other volumes. All right, so instead, we're going to take pi out to the front from 1 to 2 of 4 minus x minus 1 over 4 x squared dx. All right, so we're going to have pi from 1 to 2. Actually, we can just integrate it from there. I'm looking at it like, should be fine. So we're going to get 4x minus x squared over 2 minus 1 over 4 times 1 over 3 x to the third, all from 1 to 2. So we're going to get pi times 4x minus x squared over 2 minus 1 over 12 x to the third power. from 1 to 2, and then we can input. So we're going to get pi times 4 times 2 is 8 minus, so 2 squared is going to equal 4 over 2, so that'll be 2 minus 2 to the third power is going to be 8, so 8 over 12 minus, we're going to have input 1, so 4 minus 1/2 minus 1 over 12. So then we're going to get pi. 8 minus 2 is going to equal 6 minus 8 over 12 minus 4 plus 1/2 plus 1 over 12. So we're going to get pi 2 minus 7 over 12 plus 1/2. We get pi 12 times 2 is going to equal 24 over 12 minus, we'll just combine these real quick, as 1/2 will be 6 over 2, so it'll be 1 over 12. So we're going to get pi, we're going to get 23 pi over 12 should be the answer. And it looks like I did some, 1 minute, did I do it right? Oh no, because this is supposed to be a minus there. And this is 1/2. Let me check. Okay, I'm getting something different than what the solution got, which is why I'm taking a look for number 1. So this is 4 minus 1 minus 1 over 4. They got, I think, 2x right here. I don't know how they got that, as it's a minus 1/2. Just, my value's a little high, or a little low. Yeah, no, a little high. So 2 minus 2 minus 8 over 12 minus 4 minus 1/2 minus 1 over 12. Okay, so I don't know if, so I'm getting a totally different integral right here. If anyone wants to take a look and just tell me if I'm doing this wrong for factoring, but the book is saying it should be minus 2x right there. My expansion is incorrect. Okay, that might be it. Let's see, we got 4 minus 1. Oh, I see what I did wrong. Okay, yep. I forgot that this is not a 1, and I just assumed it was a 1. So this should be minus 2, which means that is done. That is done. So instead it's going to be minus 4, and instead of this being 1/2, it's just going to be 1. So instead of this being 6, it's going to be 4. Instead of this being 1/2, it should be 1. And then when you added these together, they should have canceled out, so this should be 0. And then, let's see, this is okay. 7 plus 1/2. So pi over 12? Did I fix that correctly, or should I just redo it? And I just realized I probably, did I do this correctly? Yeah, no, 1/2. No, that's fine. So from 1 to 2, I'm just going to give it another shot because it still was not matching up. All right, so that will be pi times 8 minus 2 squared minus 1 over 12 times 2 to the third power minus 4 minus 1 minus 1 over 12. So that'll be pi 8 minus 4 minus 2 times 2 is 4 times 2 again is 8 over 12 minus 4 plus 1 plus 12. So we get pi let me just check. So 8 minus 4 minus, I did this wrong. I just realized this is supposed to be plus because a negative times a negative is a positive. All right, let's see if that fixed things. Because that means this is instead positive. That is negative. All right, so 8 over 12 plus 1 minus 12. I still think that is a little high. I think I may have done something else wrong. 4x minus x squared plus 1 over 12 times x to the third power from 1 to 2. 8 minus 4 plus 8 over 12 minus 4 minus 1 plus 1 over 12. Okay. So that'll be pi times, so we're going to add a 12 to the 8, so that'll be 20 over 12 minus 12. Which that, I think one of the values is not supposed to be here. Should be 1, yeah, this should be 1 over 12, yep. Thank you, Ethan. So instead, this is going to be 7 over 12 plus 1, and that should equal pi times 1 over, that's 12 plus 7 is 19 divided by 12, and which is the correct answer. Okay. So I guess on to the next one, which will be number 3. Yep. And that did it in red. select. Okay, there we go. Okay, so number 3 is x equals 2 root y, x equals 0, y equals 9 about y. So then let's just draw our little chart, or no, graph. So we have x equals 0, so that means regardless of y value. We got y equals 9, so regardless of x value. Then we have x equals 2 times the square root of y. So when y equals 0, x will equal 0. When y equals 4, x is going to equal 4. And y equals 9, which will be even further. It'll equal 6. And it will keep approaching the axis of 9 until at some point it will cross. So when we draw our shape, we're going to have it so that this is 9. And it should look something like this. And as we are finding about the y-axis right here, it's going to be this area here. So we're going to need to use the washers on this, I believe. And it looks like you can also use cylindrical, the cylindrical shells. This is right now washers. We might be able to do cylindrical shells after. So that's going to be our first R, and we're going to have a second R that goes further out. So for this, in order to solve this, we're going to have to take the integral from 0 to 9 of pi, and then it's going to be big R squared minus little r squared times dy. Or actually, no, is this, yeah, it should be dy. Yep. Oh, wait, this is about the y-axis. Oh, I see what I did wrong. Because that looks like it was for dx. So it's going to instead look like this on the other side. So we're having to find from here to here. So this is just going to be a disk. Which means we're going to have to solve for dy right here. And our radius, r equals x. So that means r equals x, which equals 2 root y. And we're going to have to evaluate this from 0 to y. No, 0 to 9. So from 0 to 9 of pi, and then we'll take the radius, which is 2 times root y squared dy. So then we're going to get we're going to take pi out to the front from 0 to 9 of 4y dy. It'll be pi times the, we'll just take the integral, so divided by 2y squared from 0 to 9. All right. I'm taking a second. So I don't know what for. Let me just get that back up again. It's surprisingly saved the progress for where we were at, though. All right, there we go. And now it's so much more responsive. Okay, so we're going to get pi. We're going to input 9, so that's going to be 4 times 9 squared over 2. And then it's going to be minus 0. So it's going to be 4. No, it's going to be pi times 4, so 9 squared is 81 over 2. And then 81 times 4 equals 4. Then 8 times 4 is 8, 16, 24, 32. So it's going to be, and then we can actually take 2 out of that. So 324 divided by 2, 1, that'll be 6 and 2. So 162 pi over, that should just be the answer, 162 pi. Let me check the answer real quick. 162 pi is the correct answer. Okay. So now on to number 5. So 5 is going to be y equals x to the third power, y equals x. X must be greater than 0. It looks like it's almost saying greater than or equal to, but yeah, I think it's a greater than 0, and it's about the x. So we're going to create our graph real quick. So we got x must be greater than 0, which will mean that we're going to have this here. So for regardless value of y, we have y equals x. So let's see, we'll set this equal to 1, 2, 3, 4, 1, 2, 3, 4. And actually, you know what? Let's make this, let me change the scale real quick, as I just realized we're dealing with x cubed and x. So we'll set this equal to 1. This is 1, 2, 3, 4. 1, 2, 3, 4. That'll be also equal to 1. And this will be negative 1. So this is going to be the graph of the linear, so y equals x. And then y equals x cubed is going to be like this one right here. So when we draw this on the other side, so we're going to need to use the washer method for finding little r here and large R here. So for this, we're going to have to take, and let's see, we're going to want to use, it's going to be dx. So we're going to want to take the integral from 0 to 1 of our big one, so that is going to be x minus, well, let's see, we have big R equals x, big R equals y, which equals x, as it is just this. And then little r also equals y, but instead it's going to equal x to the third power. All right, so it's going to be x minus x to the third dx. Okay, so from here, we will integrate. So we're going to get x squared divided by 2 minus x to the fourth power divided by 4. All of that from 0 to 1. So then we're going to have x over 2 minus 1 over 4. Or no, we're going to have 1 over 2 minus 1 over 4. Which that's just going to equal 1 over 4. And then let's just check the answer real quick. And I've just realized I forgot the square root and I forgot the pi. Which is kind of a little late in the problem, but not too bad. So it should be squared, and we should have a pi out front. Okay, so we're going to take the integral from 0 to 1, no, of pi times the integral of 0 to 1 of x squared minus 2x to the fourth power times x to the sixth power, no, plus x to the sixth power dx. Let me just make sure that's right. All right, it's 1 minus. I think I may have done this wrong. Unless I can't factor that x out, which also could be, and I don't think I can actually factor it out. That would be x minus x to the 3 times x minus x to the third. Yeah, I'd have to take an x squared factor out instead. Okay, then I did it right. Okay. Yeah. Oh wait, these are squared separately, so I can't, so I have to take, okay. So then let me rewrite this. So the integral of from 1 to 0 of pi times big R squared minus little r squared dx. So take the pi out to the front, so that is going to be x squared minus x to the third squared, which will be x to the sixth. Dx. Okay, and then from there, we will get, oh, and then we have to integrate. So that'll be from pi, so that'll be x to the third power divided by 3 minus x to the seventh power divided by 7. From 0 to 1. So that's going to be pi times 1 over 3 minus 1 over 7 and 1, I think, yeah, 1 expression. Yep. Let me just reshare my screen to finish this up. All right, there we go. So it's pi times 1 over 3 minus 1 over 7, and then minus 0. So that is going to be pi times 7 over 21 minus 3 over 21. So that is going to be pi times 7654 over 21. So that's going to be pi times the 4 pi over 21 should be the final answer, which is the final answer. Okay, if anyone has any specific questions, I guess we can go over that also. Otherwise, I'm just going to call it at this because OneNote keeps crashing. At least for me, this corrected a lot of the stuff because I was making, as you saw, I was making mistakes. I totally forgot the formula for this, so. Check Discord. All right, I think that is going to be it for tonight. I'm going to wish everyone best of lucks on your exam, as I think we're all going to slightly need it. Yeah. Let's just hope that no one has everyone gets their stuff figured out tonight, so we don't have what I pretty much did for half these problems happen on the exam, and we only score half points, because that will be no fun. All right, I'm going to stop the recording.